This is section 11.2, and we're going to continue with our chapter on limits, and we're going to talk about continuity. And here is a pretty good formal definition of continuity. A function f is continuous at x equals c, so at some number, if the following three conditions are satisfied. F of c is defined. The limit of f of x as x approaches c does exist, and that 1 and 2 are equal. The limit is equal to f of c. If f is not continuous at c, it is discontinuous there. So ultimately, we have to have an f of c. It has to be defined. There has to be a limit that is there, and those two things have to be the same. So here's an example. This is a piecewise function from here forward. So for x greater than 0, it's this line. For less than 0, it's this line. Is this function continuous at x equals 0? So you have to determine from the left and the right. So the limit as x approaches 0 from the left is equal to -1. As we come in this way, the y value is -1. As x approaches from the right, the y value is 1. So since the limits from the left and the right are different, the limit does not exist. Number 2 on our definition fails. If we look back here, the limit does not exist. So that is not continuous. And here's just a chart for information. Polynomial functions, they're continuous for all x. It's one of the things we know. We don't have to really think about it. For rational functions, it's continuous everywhere except where the denominator would be equal to 0. So right there is a break. That's a vertical asymptote. That's where it's not continuous. Square root function, anything under the radical, whatever that is, has to be greater than or equal to 0. So that would be where it might not be continuous. Exponential function, a to the x, continuous for all x's. And logarithmic, it's for all positive numbers. That's just general information. Here's another example of a piecewise function. We don't have a picture of it. So we're given these three pieces are part of the function. Here's the parameters. So this is for x less than 0, this is for x between 0 and 3, and this is for x greater than 3. So you look and say, where are the possible breaks here? Well, possibly at 0, possibly at 3. So we have to try both of those. So we check on the left of 0 and the right of 0. Well, the left of 0 would be this piece because that's x is less than 0. So the limit there, if we plug 0 in for x, we get -4. On the right, well, this is greater than or equal to 0, so we would say x squared. And if we plug in 0 there, we get 0. Well, those two items are not the same, so it's not continuous at 0. Then we check on 3. To the left of 3, less than or equal to 3, this piece. So if we plug in 3 there, we get 9. To the right of 3, greater than 3, if we plug it in there, we also get 9. So at our 3, it is continuous. It is not continuous at 0. So that's what we need to do if we have a piecewise function. All right, let's look at some problems and try that. All right, number 1 gives us a graph, and on your computer you could certainly make this a little bit larger, but it asks us several things. So for the first part, it says find the limit of f of x as x approaches a from the left. So as we approach a from the left, and we found our a that we're worried about by saying where is it discontinuous? And it's discontinuous at 3. So we're letting that be our a. So as we come into 3 from the left, the y value is up here at 9. As we come in from the right, the y value is 3. So that's what they're asking here. Remember that A with the minus sign means from the left. A with the positive means from the right. And then it says, okay, what's the general limit? Not left or right, but just in general. Well, if those are two different things, then the limit does not exist. Next, it wants us to find f of 3. Well, if we look at 3, where's the closed-in circle? It's up here. So f of 3 is 9. Which conditions for continuity are not met? Well, f of 3 existed, but the limit did not exist. So that was the one that didn't work. Number 2, find all values x equals a where the function is discontinuous. Well, it's fine. Here, it has something there. So at 1, 2, 3, 4, 5, -5, and at -2, we have this break. So at those two places, it is discontinuous. Number 3 is a rational function. Remember, the denominator cannot be equal to 0. So we take that denominator and we do set it equal to 0 to find out what values would make it be 0. 0 and 1 when you factor it and you set each of those equal to 0. So there's a discontinuity at x equals 0 and at 1. 4, this is a polynomial. And remember from the chart, we said all polynomial is continuous for all values of x. So we have b, it's continuous everywhere. Number 5 is a piecewise function. Here's our places, here's our parameters. The possible discontinuities, there's something at 1 and something at 4. So let's try 1. From the left, when we take the limit as x approaches from the left, that would be this way, our value is 2. As we come in from the right, it's this piece, so if we plug in 1 there, we get 2. So the limit is existing, that's great. Now what is f of 1? Well, f of 1 has to be in this piece. If I plug in 1 there, I get 2. So f of 1 is 2. All three of those things are the same number, so we have that it is continuous. All right, then they ask us to do the graph of this, and you could do that one by hand if you didn't want to put it in the calculator. For less than 1, it's a horizontal line at 2, so we have that. And between 1 and 4, we have x plus 1, so you would have a y-intercept at 1, which isn't part of it, and then you could see that that would be that piece of the line. And for x greater than 4, it's a horizontal line at 4. Now, those two look very much alike, these two right here. But on this one, x is greater than 4. That's that piece looks like it should have an open circle, but it was already colored in by the x is less than or equal to 4 piece there. So it's actually C. And so if you're looking at the graph, it's continuous for all values of x, which is what we found here. Do the same thing with number 6. We're going to check this at 0. If we come in from the left and we plug in, we get 14. If we plug 0 in to the right of 0, we get 9. Those are not the same, so this is discontinuous. You could put this in your grapher, or you could kind of look at it by hand. So for less than or equal to 0, it's this straight line, 7x plus 7. And for greater than 0, it's the quadratic. It is this one because x is less than or equal to 0. And for this one, it's greater than 0. So we have this. It does have a hole at 0. So that should get you through the idea of continuity.